Okay, so here we go. Yeah, you will actually. So why don't you do this? If you log in, if you close it down, I mean, then when you open it up, are you right back where you started?
Yeah.
Yeah, do that. Log into Moodle and then close it up. Okay, what I want to do today, we're moving on to a new section. We're going to talk about function transformations. And so the idea here is, can we come up with ways that we can, in a really organized and predictable way, can we come up with ways that we can take the graph of a function and we can turn it into any graph that we want it to be. Now, not any graph. It has to be of the same original type. Like, for example, if we were to take a parabola. Parabolas have a distinct shape, right? But parabolas come in all shapes and sizes. They can be kind of stretched out, or they can be kind of squashed down, or they can be reflected, or they can be moved around. But they all have a parabolic shape, right? We're going to deal with, for the most part, we're going to deal with functions of x, and so our parabolas are always going to either open up vertically or open down vertically. Does this stuff sound familiar? A little bit. How familiar are you with the graphs of parabolas? Give me a 1 to 5. I mean, you guys dealt with this last year a little bit. So just kind of, 5 means I know everything there is to know about graphing parabolas, and then on down to what's a parabola. Yeah. All right. So, okay, that's about what I'd expect. That's fine. So we're going to move, that'll be a 5 here soon. I want to look at this in terms of, we're going to just kind of do a little exploration here. So let's go. Let's look at what happens if we take a really simple graph. And I'm just going to use Excel for this. Just let's see if I go make this a little bigger. There, how's that? Okay, so let's do a couple things. Let's just start off, let's just look at this part right here. Okay, so just making a little table. Excel is really good at illustrating algebra, because when you use Excel and you make, how many of you used Excel? Use little formulas in Excel. Okay, that's algebra. I mean, that's exactly the same thing we do with variables in algebra. So we got a little column of input values, 0 through 10, and then we're just going to program some output values, where we're going to take the input value and we're just going to square it. So this represents the function x squared. And so if I go up here and look at the, what do I get? Squaring something is multiplying it by itself. I forgot how to square something in Excel, so I just multiplied cell A2, which is that one right there. I just multiplied that cell times itself to give me that value. So 0 times 0 is 0, 1 times 1 is 1, 2 times 2 is 4, etc. Right? The nice thing about this is, with Excel, all I have to make is one row, and then I can just drag that formula down, and it copies that same formula all the way down. And you're probably real familiar with that. Okay? So if we look at this, this doesn't look too remarkable. And let's actually model this with maybe a real-world situation. Let's say you got a great job where for every hour you work, it's going to square the number of hours you've worked, and that's going to be your pay for that hour. That's pretty good, right? So the first hour is pretty bad. From 0 to 1, you're not making anything, but then it picks up after a while. After 10 hours, you're making $100 an hour. So that's pretty good, right? Let's graph this thing. So to graph this, all I've got to do is, let me go to my, oops, hang on here. That's not the one I want. I'll just grab a new one. How about? Oh, hang on. I've got one here. I know I've got one. Is that it? Oh, I'll start it. I guess I don't. All right, so all I've got to do is if I go back to, and this is really cool, this is something, I want you to learn how to use Desmos well, because you're going to use it a lot in the future in math. So if I just grab these first two columns, and I'll just go from 0 to 10, and I copy that, look what happens if I go into Desmos and I paste it. That's kind of cool, right? It makes a table. Okay? So it gives me a table of values, and what's that look like? Half a parabola, right? And you can see what I'm graphing here is my pay, my hourly pay as a function of hours, right? Everybody see that? Okay. So let's make a prediction then. What's going to happen if I get a bonus? And so I've worked so well, I'm such a good guy that in addition to my normal pay, they're going to give me an extra $25 on top of my hourly wage every hour. Now, what's that going to look like in terms of the spreadsheet? Well, let's make it $40. What do you say? I'm just going to delete these. We'll just make these from scratch. So if I want to do, we'll make it 25. So if I want to make an extra $25 an hour, what am I going to have to do to all of these normal hourly amounts? Just add 25, right? So all I've got to do in Excel, I hit an equal sign to indicate that I'm going to make a formula. And then I'm just going to say everything in that cell right there plus 25, right? So that's going to give me, as expected, all these amounts plus 25. No big deal. What would that look like in terms of a formula? F of x equals what? X. Okay, and actually, let's do this in terms of, I'm going to do this differently. Let's make this a new function called g of x. And let's write this in terms of f of x. It's just going to be whatever f of x was plus 25, right? Genius. So far, so good. Okay? Let's add this to our, just to verify that we had this right, let's just add this to our Desmos graph. Whole thing, yeah, we'll just go clear over the top of it here. We'll just delete this, and we'll paste that. So what do you know? That looks about right, doesn't it? We just took the blue graph, and it looks like we raised it up by 25. We can. Would you like to do that? A line? Would you prefer a line or a parabola? What do you think? What line do you want? The green one. Okay, so you want the green one. Well, let's do both of them. But if I want to represent that in Desmos, like let's take the blue one first. What would I graph? F of x equals x squared. And what do you know? We got to get the colors right, though, don't we? That's wrong. Blue. There we go. How's that? Okay. And if I want to do the green one, what would it look like? Okay, so we'll call it f of x. I could call it g of x, you're right. I'll just say f of x plus 25, and I got the color wrong again, so let's fix that. Much better. Okay. Look good? Okay. So, got a different proposition for you this time. So would you like to, what if somebody said, okay, I've already, they go home sick, a lot of sickness going around, but they've already worked 4 hours. So they're going to give you their 4 hours, and you're going to pick up where they left off. That's a pretty good deal, right? Okay, why is that a good deal?
Because you don't start with 0.
We're not starting from 0. We're starting maybe further along the graph. Does that make sense? Right? Okay, so what's that going to look like? Let's go back to Excel. How could I say that one? What's that formula going to be? If I go into Excel, what am I going to do? Okay, so I could do the quantity x plus 4 squared. That's one thing we could do. Gosh, anybody know how to do that in Excel, how to do a power? Let me try just doing it with a exponent. I don't think it'll work. So there's x plus 4, and let's just see if this works. Oh, it does. What do you know? Okay. Okay, what do you notice about that? So there's a 16 as my output. There's a 25. Where do you see those? Right there. Okay, so that goes with that, right? For example. Doesn't that make sense, though? If we're starting, if they've already given us at 4 hours, we're starting 4 hours in with our, right? We're making $16 instead of 0 for the first hour, 25, right? What's another way we could write that formula, though? So here we said our input plus 4 squared. How could we write it in terms of our original output? I mean, we could just offset this also, couldn't we? Right, I could just say this is just going to be, if I could put equals f of 4 right there, squared. Oops. Oh, right, I did the wrong one. I meant to do A6, not B. Here, let's start over. Should have done this guy, right? We're doing the input squared. So we're just going to start 4 hours in. And what do you know? I get the same values, don't I? Right? So how could we label these then? Well, this one we could call, maybe we could say this is some function. This is going to be x plus 4 squared. This is just g of x. Let's call it h of x. How about? Equals f of x plus 4. Everybody agree?
Yes.
Everybody agree? Okay. Same thing. Okay, what's that do? Let's copy. I guess we can just delete this one though. How about? Okay, and let's copy all these and see what that does. What's the prediction going to be? What's it going to do to the original blue graph? It's going to move it up? How many people say it's going to move it up?
Yeah.
Okay, how many people say something different? What's the suggestion? Move it over to the left, because what did we do here, right? We didn't, right? I mean, what did we say? We said that you're going to borrow some hours for somebody. They already started 4 hours in, right? So instead of starting from scratch, you're starting from where they would have been at hour 4, right? So once again, think about that. What's that going to do to the graph?
Move it up and X. So X will be Y will go to 16.
Okay. Now the green one clearly got shifted. Our math were to be translated up. I don't know what color this next one's going to be, but what's it going to do? Let's see. Let's just put it in there and see. Oops, I guess I got to put them down there. So the colors got messed up. Let's fix the colors. So this one's supposed to be purple now. Gotcha. And this one's supposed to be black. Okay, what did it do? It looks, did I mess something up there? Looks like hang on, I must have done something wrong. Let's go back to Excel. What did I? Oh no, it just, okay, here's why. It just looks that way because the graph isn't very big. If I pan out, you can see that it's kind of getting a little curvier. What could we do to maybe see all the curvature though? Let's go back to Excel and yeah, how about if we add some extra points? Let's do this. What if I insert a bunch of extra cells? So let's insert some blank spaces and let's continue this trend backwards for negative values of the input. So we'll go backwards in time a little bit here. Now let's check this out. Well, that looks a little better, doesn't it? Okay, I got the colors wrong again, though. That's kind of getting annoying. Red, blue. Okay, so let's get rid of the blue one for a second. So there's the original red one, right? What did it do? What did it do? So when we added that 4 inside the function, right? We added 4 to the input values. What effect did it have on the graph? It's pretty clear.
It moved the relative low to -1.
Okay, so it scooted it left 4, correct? Which still, that's advantageous to us, right? We like that because look where we're starting. We're already starting. Normally we would have had to wait 4 hours to get that much pay. We're starting right there, right? You get the idea? Okay. So then now let's see if we can make this a little bit. Tell you what, open up your Chromebooks and take a second and just go here. Go to, I'm just going to let you play a little bit here for a moment. Go down to Unit 3, 3.4, and go down to Interactive Transformation Fund. Okay, you're going to see, now just take a look at the first and the second links. Just look at those for now. First and the second links, and just go in and mess around a little bit. It's going to take you about a minute. But the first one, if I click it, takes me here. So it takes you to this graph where you've got this, what we talked about. We've got y equals x squared, and we're going to add some value to it, right? So this is the first thing we did, right? We got a bonus. If we drag this thing around a little bit, just watch what happens. Not surprising what happens, right? Just mess around with that, and then go to the next one. Mess around with that a little bit. Next one's a little trickier. Now we're going to drag around. We're going to take some value inside the function, and we're going to, now notice I put a negative sign there. I want you to tell me why. In a moment. Okay, mess around with that a little bit. You can drag this little slider down here to pick up values of h. And subtracting a negative is equivalent to what? Adding. Okay. So, what'd you find? What'd you find? So, pretty obvious. What if we just add a constant to a function? What's that going to do? What's it do to the graph? Move it up, right? If you add a negative value, same thing as subtracting a value, what's it going to do?
Move it down.
It's going to move it negative up, which is down, right? So we know we can summarize that pretty easily. So in terms of the parent function f of x, we can do a really simple transformation. We're going to call this value the vertical offset, right, or the vertical shift. We're going to assign a letter to that, right? It's always going to be represented by k. K is a parameter of the function. So close those up real quick. I know it's hard to tear stuff away from all that math fun, but we'll get back to it, I promise. So the parameter k represents the vertical shift. Very simple. This is what we'd call an outside transformation. Outside transformations are easy. They're transformations you're doing to the output of the function, and they're very easy to manage, right? By adding something to the y value, you're literally picking it up in the y direction, okay? And we saw that on our table in our graph, right? The original values, output values, they just all had 25 added to them, which literally just picked this thing up. You can see now, I guess I did it. Oh, there we go. It just moved each of these up by Right? No big deal. Now the one that's a little tougher, maybe to wrap your brain around, at first at least, is this guy, the inside transformation. What'd you find? What'd you find? If we introduce a new parameter h, and h is the value that we're going to add or subtract to the input, not the output. So this is an inside transformation. These are a little tougher. What'd you find? Moves it sideways. How can we make a prediction about that? What happens if we subtract a value from x? In which direction does it shift the graph? You sure? Because we added. Well, what did ours do? We added 4 hours to our original amount of time we'd worked, and it was to our advantage because it actually shifted the graph in which direction? To the left, right? It shifted the graph to the left. So when the time was 0, that moved us further up the graph, right? Imagine if we look at the picture of what we did. Imagine that there's like a bead on this spot right here that's kind of fixed at 0. When I slide the red graph over to make the green graph, well, isn't that bead going to get moved up this vertically along with the function, right? That was helpful, okay? So when we added a value to x, it moved the original parent graph, we could call it, the starting graph, we call it a parent graph in math. It moved it left by the amount that we added, correct? Now we want to, just like we wanted to define a vertical translation in terms of the positive movement, which in the y direction is up, we also want to do that with a horizontal translation or shift. We want to define our parameter in a way that when we plug in a value, we're going to get a positive shift, a shift in the positive x direction. And so for that reason, look how we represent this. And we don't say f of x plus h, we say f of x minus h. What would have happened if instead of adding 4 to the graph, we didn't do it, but what would have happened, you saw it when you played around with this stuff. What happened when you subtracted a value from x to the original parent graph? It shifted in which direction? To the right, in the positive direction. So we're going to define our parameter in this way. We're going to say that if we want to invoke a horizontal shift in our function, we're going to plug in a value for h, where h fits into the template f of x minus h, and h represents the positive shift to the right. Okay? So if I did something like f of x minus 3, the value of h is what? Like what's the value of h here? 3, not negative 3, it's positive 3. Right? Because we're subtracting h from x. What's that going to do to the graph? It's going to shift it in the positive horizontal direction, meaning to the right, by 3. Okay, everybody get that? Okay, let's look at maybe one more. So, let's start what we got here. When are we out of here? 25. Actually, we'll save that for tomorrow. So now let's look at a couple sample problems from Moodle on this. The assignments, they're not hard. So you got 2 assignments over this. Pretty straightforward, pretty simple stuff. So things like this. So what do we do? If I want to write g of x as a function of f of x, what do I do here? F of x I don't know what f of x is necessarily. But if I'm just writing it in terms of f of x, what would I have to do to go from red to blue? Add 7?
Oh,
Because we're starting, the red graph is the parent graph. That's what we're starting with. To make the transformation to get the blue graph, what did I do? Just describe it for me, not even mathematically. What did I do to go from red to blue? So I made it go down 7, right? I shifted it down, so that's a vertical shift. What would the value of k have to be if we're going down 7 is going negative up 7, right? So what am I going to do? What do you think? What did we say? If I want to do a vertical shift, let's go back. Let's go back there. What do I have to do? K is the amount of the vertical shift. Well, what is the value of k? Negative 7. Yeah, so I'm just doing f of x plus negative 7, or f of x minus 7, right? Okay, make sense? I'm a superstar.
You come up with some new ones, Bob?
What's that?
You come up with some new bases?
Yeah, well, no, because I don't have time. Another year, not this year. So what about something like? What about something like that? What'd I do there?
You subtracted from the
So what's the value of h here? 3, right? But remember, I'm starting with the template. Oh, darn it. Horizontal shifts are given by f of x minus h, where h is the value of the horizontal shift, right? So this is going to be f of g of x is equal to, I'm just filling in the blank, f of x minus 3. Oh, how about that? Nice going. What do you know? Okay. So then we can do both of these at the same time, and that's not a big deal. So what's going on here? Look at, I've got this g of x is a transformation of f of x. What's going on? What are the two things I'm doing? Good. So it's going right negative 1.5, isn't it? Because what's the value of h there? Let's take a picture of that. So pick out, what's the value of k? That's the easiest one. That's the outside transformation. What's the value of k? Okay. So k equals 9.5. So that's telling us up 9.5. What's h? It's negative, isn't it? Right? This is telling us right here that h is equal to negative 1.5, because that's what I just subtracted. I subtracted a negative to get a positive. So that's telling me it's being shifted left by 1.5. Right? Everybody see that? I know that's not difficult, but I guarantee some people are gonna Oh, whoops, sorry. It is. You're right. Negative 9.5, so it's going down 9.5. Good. K is negative 1.5 because of that, right? And so you can kind of have a quick rule of thumb then. You know that, I guess, when you're dealing with an inside translation, you always know that it's going to be opposite of whatever that operation is. But in the back of your mind, you want to remember why. You want to remember why, because it's related to exactly f of f of x minus h plus k, right? Okay, so the last couple problems on this, now, this is a little bit different. Okay, they have to do with translating parent functions. So if I do something, let's take just a quick look at these. What do I mean by that? I know I'm probably going to run out of time, but I want to get as far as I can. So if I take some different function, like f of x equals x to the fifth, how would I write a graph? I want to do this one. How would I do this? Okay, what's that going to look like? So my new graph, my new parent function is f of x equals x to the fourth. Okay, so what's this part? How am I going to do this part? If I want to go down by 7, what am I going to do? I'm going to just subtract 7 from the whole thing. That part's easy, right? That's just going to go to subtract 7. How do I do this part, though? How am I going to go left by 13? Okay, that's got to be an inside transformation, right? Well, what's the part of the graph that we're inputting? The inside part is, in this case, x. Right? So I've got to replace the whole x. I've got to replace that with the quantity instead. X plus 13, right? Minus negative 13. So I just got to put both of those two parts together. Everybody see that? This isn't squared anymore, but it doesn't matter. It's irrelevant what the original parent graph is. That's going to change the original shape of the curve, but the transformations that we get are going to be the same. We could do the same thing for a square root graph or for all kinds of. Now, there's an easy way to do this. There's a way to make this whole process a little simpler to think about. Okay, so let's go to the next assignment real quick. Oops. Okay, what about this? So look at the wording of this question real quick. So if we want to take a square root graph, right, we're taking the parent graph is just the square root of x. And I didn't have time to get through this today. We'll look at this tomorrow. I'm going to introduce some kind of a function toolkit, some parent functions you want to be familiar with. And then if we know what the original graphs look like, we can make these translations really easy to any parent function. In this case, we're looking at the square root of x. So if we want to make a translation of this thing, what am I doing to the original square root graph if I take the square root of x plus 5? Everybody agree I'm just moving it left?
Yeah.
I'm just going to take this whole thing and I'm going to shift it left by 5. Well, how are we going to... We want to be able to make a quick and accurate sketch of this, and so what we like to do with functions is we like to identify a special point that sort of anchors the function. What do you think that is here? What's the most recognizable point? Probably there's a pretty big hint there on that. Yeah, we're going to take this starting point of the graph, and if we shift that over left by 5, that ends up there. Oops. And then the shape of the graph from there is going to be the same. Right? So we're going to think of this in terms of special points. They're pretty predictable. Like for a parabola, what would the special point be? What do we call that bottom point?
Maximum.
Minimum? Well, we give it a V.
Relative minimum.
Starts with a V. The vertex, yep. Okay, we'll take a look at special points tomorrow.
I just wanted to say sorry I'm late, but that was my last, I took